what we are going to be doing in this video is checking the derivatives, both derivative at a point and your derivative function in your calculator. This is specifically tailored to calculators that follow the mathematical notation. So before you continue watching this video, I want you to press Math 8. If your calculator looks this exact same way, then you are watching the correct video. If your calculator shows up with, pull the math screen back up. If your calculator just shows up with nderiv on the screen, stop watching this video, go watch the video where the title says old calculators. Okay, now that we have that established, when we were doing practice 3.1, we ended up getting the derivative for the function f of x equals square root of 2x plus 1 to be 1 over the square root of 2x plus 1. I'm just going to pull that up here. In order to double check that you are actually getting the correct derivative, we are going to make the calculator calculate the derivative of this function, the f of x, and then we are going to plot it against what we got the derivative to be. So go ahead and go to your y equals. I'm going to clear that out and show you how to do that on your own. And then I'm going to clear my key history. So if you fall behind, it's there. So in y1, we are going to make the calculator tell us what it thinks the derivative is. We do Math 8. We are taking the derivative with respect to x. So click your variable button. Here we are going to we're going to write the derivative that we're taking the function of. That would be the square root of 2x plus 1. Then here, because we want x to stay in our function, we just say x equals x. In y2, we are going to type the function that we think the derivative is. The 1 over the square root of 2x plus 1. Then we are going to compare the graphs of both of these. This is going to happen very quickly on my screen, so make sure that you're looking the entire time. It's going to start graphing the blue, and then the red should graph over it. Now, keep in mind, if your original function has domain restrictions that your derivative function does not, you would apply those same domain restrictions to your derivative, but it might end up plotting more without specifying those. So really, you're just looking for some overlap sometimes and then knowing if it's plotting more, was there an original domain restriction that wasn't accounted for? But if we look at this, blue, red. You could also look at the tables if it went too quickly. I have a bunch of numbers that I randomly put into the x. I have the errors, the same numbers, and I have the same outputs for the same x values. So that tells me that I have the correct derivative function. Now, let's say that we wanted to find and check the derivative at a point. So let's say I wanted to know what f prime of 4 was. That would be 1 over the square root of 2 times 4 plus 1. So that would be square root of 9, which is 3. So I'm expecting 1/3. Let's go back to our main screen. So click second mode. I'm going to clear that out. Go ahead and click Math 8. We're taking the derivative with respect to x of, oh, I went too far. Square root of 2x plus 1. That vertical bar that you see right here means such that. So we're taking the derivative of this function such that x equals, I'm going to put 4 in there because we actually want to evaluate our derivative at 4. We got 1/3. What does the calculator get? This is essentially 1/3. Your calculator is using high-level approximating methods to evaluate this derivative. So it's actually giving us a very close approximation, but we were able to get our derivative function that we plugged into. So our answer is actually more accurate. Similarly, if you got a derivative that end up outputting 0. Your calculator might end up with something like maybe 8e negative 10. That's essentially 8 times 10 to the negative 10. And when you have those negative exponents on the 10, you're essentially moving the decimal place to the left that many times. So 8 times 10 to the negative 10, if that's what it decided to tell you. That would be move the decimal place on the 8 over 10 times. So it would be 0.00000000008. That's basically 0. So just be aware when you see answers like this, 0. That is it for this video. If you ever need a refresher on how to check derivatives in your calculator, this is where it's at.